Hello students, today's agenda is to check our homework. We're going to be doing a review of random quadratic equations, and your assignment for today is going to be 10.14. So today students will be able to review mixed quadratic equations and choose the easiest method I should put in there. Again, you can always use the quadratic equation if you wish, but I just want you guys to see that there are other, the easiest ways to find it. But if you feel comfortable with the quadratic equation, that's okay. Okay, so when I put these exercises, I want you to look at them and then start seeing what method would work best. So for example, if I have x squared equals 21, what do you think would be the easiest way? Do you think we should cancel this over here and, I don't know, use the quadratic equation? Or could we just simply, this is as easy as take the square root of both sides. And so x is equals to 21 only has factors 3 and 7, so there is nothing that we can simplify. So it's just going to be plus minus square root of 21. So those are my two answers. Okay. What if I have x squared minus 9 equals 0? Again, you can use canceling this and then taking the square root of both sides. Actually, I'm going to do both and then you can decide which method would be better. Remember that when we have the difference of two perfect squares, you just open your parentheses and it's x plus the square root of 9 is 3 and x minus 3. So your two answers will be the opposite. Remember, to make this 0, you need a negative 3, or to make this other factor a 0 will be positive 3. So that's one way of doing this exercise. Or you can just cancel. How? If we're subtracting 9, we're going to add 9 to both sides. And so x squared is equals to 9. We take the square root of both sides. And so x is equals to plus or minus 3, which is both of those answers, right? So these two are fairly simple. Again, if you were to use the quadratic equation, remember that it is a little longer. And so that's when you want to make sure you know the factoring form or the canceling form of solving this type of equation, so that you don't do the several steps that you have to do with the quadratic equation. And you can stop the video right now and try the quadratic equation and see how that one works. So you would see 3 different methods and see which one you would prefer. And at this moment, I think these are used by canceling, but I'm gonna put the list of the steps that you could take. So when you can't cancel, what you can check is to see if there is the greatest common factor. Or if it's one of those perfect squares. Either a perfect square or difference of perfect squares. Those are the two options. Or diamond, meaning when you have a third, like a number that multiplies equals that third number, or when you add them, it's the middle number. And finally, we have completing the square. And like the last one is the last one that we saw was with the quadratic equation. And remember that this quadratic equation works for all of them. It just takes a little longer. Okay, so I'm gonna have it in front of us so that we can decide, does this have a greatest common factor? Yes, because both are divisible, not for the number, but for the x. We know that the greatest common factor for both is x, because we always get the one with the smallest. And so it would be x squared divided by x is x. Positive 4x divided by x is 4. And so that's equals to 0. And remember that for my factors, my value of x will be, if it's x by itself, or you're not adding or subtracting anything, or even if we have like 2x, it will be 0. Or the opposite in here, to make this factor 0, we would have to have a negative 4. And so those are my two values. Again, we have a greatest common factor, so we can just find the factors in that way. Again, I'll go through the list for this next one. And so I'm going to check, does it have a greatest common factor? No. Is it a perfect square of some sort? It has a perfect square in here, but not in here, so no. A diamond, and again, if you need to do the diamond, that's fine. But also you can just do it mentally in here. Two numbers that multiply equals 6, but when you add them equals 5. If you need to see it in here, you can just put 6. I need to multiply the two factors. And when I add those two factors, my answer should be the middle term, which is 5. So you can see that it's positive 2 times positive 3. And so I just open my parentheses. Oh, and I would put here 2 times 3 is 6, and 2 plus 3 is 5. So either with the diamond, which is that third, or just mentally in here by observation, you can just put x plus 2, x plus 3. So x, remember that for this to multiply and that be equal to 0, one of the two factors have to be 0. So the values that x can possibly be are negative 2 or negative 3. Again, because a negative 2 in here, negative 2 plus 2 will give me 0. And then if I plug the negative 3 in here, negative 3 plus 3, that will also be 0. Okay, so these are my two answers. So again, I think this is the list that you will need to go through to make sure that you choose the right process, so that you don't have to do always the long way. Okay, I'm going to put it down here. And number 5, it's going to be x squared minus x minus 6 is equals to 0. And so, does it have a greatest common factor for all three? No. Is it a perfect square, perfect square? This one is a perfect square, but this one is not. With the diamond method, can I multiply two numbers to make it negative 6? But when I add them, it's equals to negative 3. I know that 1 has to be, for example, if I put 1 and 6, when I subtract them, because it's at 1 positive and 1 negative, when I subtract them, it's not going to be negative x, it would be negative or positive 5. What about 2 and 3? 2 times 3 is 6, and I subtract them, it's going to be 1. But this tells me the sign of the bigger of the two factors. So now let's check that. 2 times negative 3 is negative 6. 2 plus negative 3 is negative 1. So those will be my two factors. So it will be x plus 2, x minus 3. So the value of x is the opposite. Remember that. So it's going to be negative 2 or positive 3. Okay, so those are my two values. Again, it was helpful that I just went down to the third one. Now I'm wondering if I should give you, let's see, one of these just so that you can see the difference with the quadratic equation. Just so that you can see the difference and whether it would save time or not. So my a would be equals to 1. My b would be equals to negative 1. My c is equals to negative 6. And so remember that the formula is x is equals to negative b plus or minus the square root of b squared minus 4ac all over 2a. You can create a wrap if you want to, but again, in class we have been x is equals to negative b plus or minus the square root of b squared minus 4ac all over 2a. This means that this is going to change the sign of the b. Again, you can put the minus from here, and b is negative 1. So you can put it in between parentheses, or you can just know that if it's negative, that means the opposite, and you just put positive. Plus or minus the square root of negative 1 to the second power. Minus 4 multiplied by a, which is 1, multiplied by c, which is negative 6, and all divided by 2 times 1, because that's the value of a. So I'm going to put negative times negative is positive 1, plus minus the square root of negative 1 times negative 1 is 1. And then negative 4 times 1 is negative 4. Times negative 6 is positive 24. And all over 2 times 1 is 2. Again, what I did was to simplify this section right here, and this section right here. That's all I did. So 1 plus minus, I'm just bringing this down the same. I'm going to simplify this part. 1 plus 24 is 25. And all over 2. And so, sorry about that. I put the 1 in here. Plus minus, the square root of 25 is 5 divided by 2. And so now I can look for my two parts. I call it the little beans because it looks like a little bean in here. So 1 plus 5 is 6 divided by 2. Or now the other bean, which it goes this way. So 1 minus 5 is negative 4 divided by 2. And so 6 divided by 2 is 3. Or negative 4 divided by 2 is negative 2. If you notice, same answers. Look at the process and you decide which one you prefer. Okay? And so that's why we're reviewing, so that you can decide which one do I want to go with, the quadratic equation, which is wonderful because it works for every single quadratic equation to find the values of x. But sometimes it's a little longer. Okay, let me move this and do some more examples. Now let's check this again. Does it have greatest common factor? No, it looks like the 4 is for this too, but I don't have something, a multiple of 4 in here. Does it have perfect square, perfect square? Perfect square, perfect square. Now, is the square root of this one half of that? Yes, so that passes the test. And so that means that this is going to be a perfect square like this. And so what I need to do is take the square root of the first one, take the square root of the second one, which is 2, and the sign of the middle one. Now remember, these should be half of the middle term, but also the square root of the last term to be perfect square. Okay? And if you want to look at that on how it would look with the area model, this means x times x, which is x squared, is this part right here. Remember that we divide this by 2 because we have 2 in here and 2 in here out of the 4 x's. And so when I multiply 2 times x is equals to 2x, and 2 times x is equals to 2x. And then finally 2 times 2, which is this measurement right here, is the same, is going to be equals to 4. So that's your perfect square right there. X squared, 4x, and 4. Okay, same thing in here. X plus 2 to the second power means x plus 2 times x plus 2. That's your x plus 2 to the second power. Okay, so that's how we can see that this is a complete square, and sometimes we have to complete that square, but in here it's already perfect square. We take the square root of both sides, and so we get x plus 2 is equals to, now this part gets a little confusing for some people. We're going to be subtracting and adding 0 to whatever we cancel from this side. Okay, so we subtract 2. And that's where we would do this negative 2 plus 2 is going to be negative 2. And when we also subtract negative 2 minus 0, it's still negative 2. So in this case, we only get one answer. Okay? And why is that? Because when we take the square root of 0, we're adding and subtracting 0 to both sides. Okay? Only one answer. Again, that means that my parabola will touch only at one point on the x-axis. Again, we'll come back to the graphing part later on. Okay. Okay. Okay, so greatest common factor? No. Perfect squares? Yes, no. Diamond method. Diamond method means yes, the two factors that equals to 6, but then when you add them equals to 3. And if you think about it, 6 is 1 times 6 and then 2 times 3. But nothing added together makes 3, so the diamond won't work. Completing the square. And finally, you can decide to go completing the square or just go directly to quadratic equation if you prefer that. But what is completing the square? Again, it's just like coming back to this. We don't have the whole thing, right? What we have right now, and let me see if I can, whoops, that does not look like a square. Or that either. Anyways, so it's x times x, right, which is x squared. We divide this by 2, and actually that's not going to make it easy because it's going to be 1.5 and 1.5. And so when we multiply 1.5 times x is going to be 1.5x and 1.5x. And then 1.5 times 1.5 is not 6. In fact, I can multiply that, and again it makes it really yucky because it's not an even number, but 5 times 5 is 25, carry the 2, 5 times 1 is 5 and 2 is 7, 1 times 5 is 5, 1 times 1 is 1, 5, 2, carry 1, and 2. And then I have 2 decimal places, so 1, 2. So in here, it should be 2.25, but in reality, what I have is 6. That means that I end up with something like this, something bigger for this little section. And what happens? I have an extra non-perfect square. So I have to get rid of that 6 by subtracting 6 from both sides. And I'm going to leave space for that, to add that perfect square in here. But if I add it to one side, I will have to add it on the other side. Now, when do I decide if I want to complete the square or not? If you think about it, to complete this perfect square, I will have to add this 1.5 times 1.5 to make it exactly this part that I don't have in here. And do we want to work with decimals? So what I recommend is that if this is an odd number, you go directly to the quadratic equation. That way you don't have to deal with decimals in here, which you can do. You know, you can continue to do that. It's just that it's going to be a little bit more tricky and not very fun to work with. Okay? The other thing is that you can transfer them into fractions, but again, that makes it a little more messy. So why don't we just leave it at that? If you have more questions or if you want me to do it in class for you, I can go ahead and do it, or even during lunch or after school. But for now, we're just going to go ahead and do the quadratic equation. Okay? So x is equals to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and so we have negative 3 plus minus the square root of 3 squared is 9 minus 24 all over 2, which is equals to negative 3 plus minus the square root of 9 minus 24 is negative 15 all over 2. And so in here, this cannot be simplified because 15 is only 3 times 5, and so there are no pairs to cancel. And let me pull this a little up so you can see it better. And so we're going to have negative 3 plus minus. What happens when we have a negative in here? We're going to put an imaginary number to simplify that negative, the square root of 15 all over 2. And this cannot be simplified, this cannot be simplified, so that's going to be the two answers for x. So very interesting that this ended up being, how can I know that this was going to end up as a complex? Remember that complex answers is the ones that have the imaginary number. In here, you can tell that it's going to be a complex number just because when you add negative 6 plus 2.25, you're going to end up with a negative since the negative is bigger. Okay, so even with the completing the square, you would end up with an imaginary number. But again, just because of that, anytime you have an odd number in here, that's when you want to not use the completing the square, or when you have a coefficient in here, you also want to go directly to the quadratic equation. Again, when should you use quadratic equation? For sure, when quadratic equation, when b is equals to odd number, and when a is greater, it's greater than 1. Okay, so like if you have a 2 or greater than 1, or a is, let's see, maybe negative, a negative integer. Okay, so this is just a note to make it easier for you to identify, but in general, I would just go through these steps. Find the greatest common factor, or see if they have perfect square, or the difference of two perfect squares. If not, go to see if they can be done with a diamond, and finally these two. Okay, so you can now go ahead and do 10.14, and I hope this video was helpful. Thank you.